Okay, thank you. Welcome to this workshop. I just shared the link on the chat window. Uh, this is the link, sorry. This is a link to a Dropbox folder where you have material for today's session. So it has a data file, and a Word document which has a description for your assignment, which you'll be doing like today evening or tomorrow in your free time, just to practice whatever we learned today, we are going to learn today. And it also has the PowerPoint, which I'm going to use today. So what we are going to do during these 3 days, let me just turn on PowerPoint and then we can take it from there. Can you please see the screen?
Yes, doctor.
Okay. So today we are going to, little bit familiarize ourselves with the SPSS software. We're going to see that how a data file is prepared in SPSS. What are different options in the interface and things like that. And then we will talk about the measurement issues, like because you need to have a data before you run the quantitative analysis. So how to get that data, how to measure that data, what type of variables we can have. And then once you have the data, it might be in an Excel sheet, it might be on a Google form, it might be on a hard copy. How to transform it into an SPSS file, or how to import it into SPSS. And then the last thing we are going to talk about is that because whenever you get data, there are it's very rare that you get a clean, neat data, raw data. You always need to verify few aspects before running your main analysis on the data, and that process is known as data cleaning. So we will see that what are 3 or 4 things we typically look at while we deal with data cleaning. So this is what we are going to do today. And day 2, which would be Wednesday, we are going to talk about some of the assumptions which we test for quantitative data analysis. And then we are going to talk about univariate and bivariate statistics. Now, univariate statistics means that when you are dealing with only one variable. Uh, and bivariate descriptive statistics means when you have more than one variable, like correlation, association between variables. We'll talk about these things. And then on day 3, we are going to talk about things like mean comparison, like t-test, ANOVA, and regression analysis. There's a very good, very good, or I would say excellent resource, easy to read, and the people who do not have any background in statistics, uh, this is a very useful book. You can see on the slide, it is Discovering Statistics Using IBM Assesses by Andy Field. Very easy. And if you are using SPSS for your data analysis, I think this is a very good resource. So I encourage you that all of you, if you are interested in learning more about the quantitative stuff by using SPSS, this is a very valuable resource. Okay. Now, another thing which I would like to make very clear from the is that this is a basic course. While delivering my lecture, while talking about different concepts, I am assuming that you do not have any background in quantitative data analysis. So those of you who might be familiar with quantitative stuff, like they might feel that like sometimes I would be talking some basic stuff, but That is important because this is for the beginners. So this is something which I want to make clear from early on. Okay. Moving on. Now, how do we use statistics in quantitative research or quantitative data analysis? This is how typically we run a process. You know, we choose a research question. Now, what might be the research question? A research question might be, for example, you would like to see an association between quality of sleep and blood pressure. Now, that might be a research question. Okay. Now, once you have chosen a research question, then you go back to the literature and you generate hypothesis. Now, hypothesis, what is a hypothesis? We'll talk about this more about this later. Hypotheses are basically a testable statements which consists of variables, and then you test, and then you get data on those variables, and you then test the hypothesis using quantitative techniques. Now, for example, if your question is research question is you want to see an association between quality of sleep and blood pressure. Now, then next you would make an hypothesis. Hypothesis would be there is a positive association between blood pressure and quality of sleep, which means that if blood pressure, there is a negative, I would say, relationship between blood pressure and quality of sleep, which means if blood pressure goes up, quality of sleep would go down, if I'm saying that there is a negative relationship. Now, once we say that there's a negative relationship between X and Y, or between two variables, like between blood pressure and quality of sleep, we are saying that if one of the variable goes up, the measurement on one variable goes up, the measurement on the other variable should go down. So this is like how you build hypothesis, and that you build on, you go back to the literature, you go back to the theory, and from there you build the hypothesis. You can also say that hypotheses are basically your predictions. And then the next step is, once you build the hypothesis, next step is you collect data. You would collect data on quality of sleep, like you will approach patients, you will approach normal human beings. You will maybe you will visit clinics, and the people who are coming to different doctors, you just take their readings of blood pressure, and you just ask them that how many of hours of sleep on average you have every during past 24 hours. Now you will get hours on the sleep, and on the other side you will get readings on the blood pressure, and then you can put those record those variables into SPSS, Excel, or any other data analysis software, and you will run an appropriate you will use an appropriate data analysis technique to see that what is the association. So this is how typically the whole process of quantitative research is driven. So once you have collected the data, you fit a statistical model to the data. Now, when I say statistical model, this means you use the appropriate technique or tool to analyze the data based on your hypothesis, because it's like we will talk about this more, but the type of variables you have and the way your hypotheses are written, that determine that what type of statistical technique you're going to use in order to test the hypothesis. And then once you run the statistical technique, you get the result. You will see, based on the output, you will see that whether your results support your predictions or hypothesis or not. And then that translate into your findings. Either your findings or your results would support your hypothesis, or you would say that my hypotheses are not supported or are refuted. Okay. Now, hypothesis, as I just mentioned, that these are testable statements. Hypothesis always involves variables. Now, what are variables? Variables are things which are not constant in this world. For example, your age is a variable, right? Your weight is a variable. Every one of us has a different weight. If I sample 100 individuals, I will probably have 100 values, and I will see a variation. So whenever there's a variation in values, we call them the variable. How many, dates you eat in iftar? Now again, that is a variable. Everyone, maybe I eat 5 dates, you eat 1, you eat 3, 4. So this is a variable. On the other hand, like you have constants. Constant, for example, like you might be familiar with some of the constants we used in physics and maths, like pi is a constant. For example, some of the other values, speed of light is constant. That doesn't vary, for instance, and things like that. So anything which vary, where we see a variation in the reading, in the values, that is a variable, just to put it in simple terms. Okay. Typically, when we do the data analysis, we have two type of variables. One is one is independent variable, and the other one is dependent variable. Now, independent variables, another term we use for independent variable is predictor, and dependent variable is, we also use the term outcome. Uh, Now, we will talk more about this in the regression. Uh, Independent variable or predictor is the one which predict the other variable. Now, for example, if you look at these two examples which I've put here on the slide, is blood pressure is negatively associated with heart health. Now, is there anyone who can tell me two variables in this statement? Anyone? You can just raise your hand if you want to answer. Yeah, Halima.
Yeah, hi, doctor. Hi, everyone. So
Yeah.
here we could see that the blood pressure is the independent variable and the heart health is the dependent variable.
Okay. But the way I appreciate that you identify both the variables. Blood pressure is one of the variables, and heart health is the variable. But we like, for instance, the reverse is equally true. We can also say that heart health can also predict blood pressure, isn't it? For example, if your heart health is good, most likely you are going to have a normal blood pressure. But if your heart health is not good, it is going to lead to the bad blood pressure readings. So from that perspective, we cannot say that which one is dependent and which one independent, because we can see that the blood pressure can predict heart health, and at the same time heart health can also predict blood pressure. This is the issue of causality, that which one is causing which variable. Is the blood pressure causing heart health, or heart health is causing the blood pressure? So sometimes, like for example, we are not sure, and there are techniques through which we test causality, that which is X causing Y or Y causing X. Now, for example, if you go to the next statement, BMI is positively associated with obesity level. Now, the higher the BM is, the more the obesity level is. Now, here also we have two variable. One is the BMI, and the second one is the obesity level. Now the idea which I just want to uh, give you here is that we can only test a hypothesis if we have the variables in there, and we should have the direction that is just positively related or negatively related. Only then we can test, uh, and at the same time that variable should be measurable, like that should not be a constant. Now if you look at these two statements, blood pressure we can measure and we can see variation across it, heart health, see variation across it, and the other BMI we can see variation across it, and obesity variation across it. So if you look at these two hypotheses or these two statements, we can see that we in each statement carries two variables, and we can measure these variables. So once we have measured them, then later on we can test those. There are two other types of variables as well, which we call them moderators and mediators, but that I leave to the more that is a kind of more advanced topic. So we are not going to talk about here. So for the time being, we'll just stick our discussion to the two types, which is independent and dependent variables. Okay. Now once we measure variable, we can have the measurement at two levels. We can have a categorical measurements and we can have a continuous measurement. Now, for example, in categorical measurement, we have three further types. Now, the first one is the binary variable. Now, binary, as the name suggests, it has only two values. For example, dead or alive, pass or fail. So all those variables which where only two categories are possible, we call them the binary variable. Old or young, for instance, uh, university or school, for instance. Uh, then the next categorical variable is a nominal variable. Now, when we have more than two categories, we call it a nominal variable. For example, if someone is omnivore, vegetarian, vegan, or fruitarian, now it has four categories. That is a nominal variable. Now, for example, what is your marital status? You are single, you are married, you are divorced. Now, that is a nominal variable, like we have more than two categories. What is your sex? Is it male, female, transgender? So we have three categories. So again, that is a nominal variable. What is your qualification? Is it like high school, undergrad, grad, PhD? Again, that is a nominal variable, but we can also call it as ordinal. Now, ordinal variable is a type of nominal variable where we see a logical order among categories. Now, for example, if again, if I give the example of qualification, so we can have like high school, undergrad, grad, PhD, DBA, for instance. Now that is, uh, you can see that is an ordinal variable. Now, which you can arrange the categories from a lower order to a higher order. Now, for example, your grade in your courses, like you get an A minus, B plus B, C plus C. Now, again, this is an ordinal variable because we can see that there's a logical order, high to low, low to high. Similarly, whether people get a fail, pass, merit, or distinction in their exam, now that is an ordinal variable. Now, these variables, we don't call them the continuous variables because they have distinct categories. Now, binary have two categories, nominal have more than two categories, and ordinal have more than two categories, but you can order them according to a logical order. So these are the three types of categorical variables. The second one is the continuous variables. Now, for example, blood pressure, your marks, height, age. If I ask that what's your age in years, that is a continuous variables, or age in months. So these are the continuous variables. Now, why we are talking about these variables? Because if your dependent variable is categorical and independent is continuous, you have to use a different statistical technique to test that. So the type of variables determine that what type of statistical technique we are going to use to test our hypothesis. So that's why it is important to first see that what is the nature of your variable. Now, for instance, when we collect data, we collect some categorical variables as well, which we also call them demographics. For example, you collect data on the maybe the qualification, you get data on age. Sometimes we make age as a categorical variables. Now, for example, we say, what is your age? Less than 25 years, between 25 and 30, between 30 and 35, between 35 and 40, above 40. Now, you see, like we have made 5 categories. We have converted a continuous variable into a categorical variable. We also ask them, okay, what is your marital status? Sometimes we ask people what are their qualifications. Sometimes we ask people there in which you live in which city, Abu Dhabi, Dubai, Al Ain, Fujairah, Ras Al Khaimah, for instance. Now, all these are categorical variables because they have distinct categories. And sometimes we use, these categorical variables, we control them. We also call them the control variables sometimes because we control them, the main analysis while we are testing our hypothesis. So that's why it is important to know, to understand that what is the nature of your variable. Okay, moving on. Okay, so now we'll talk about SPSS. SPSS is one of the most widely used statistical software people use in social sciences. And SPSS stands for Statistical Package for Social Sciences. So now what I'm going to do, I'm going to, because this is not how you are going to learn it, I'm just going to now open the SPSS and we'll talk about that. We will just like get ourselves familiar with the interface. We'll also see that how you can import data from Excel or other data entry, or like how you can enter data by yourself, or how you can copy paste data from different things. Okay, now before going to the SPSS, let me talk about some of the basic terms which probably we will come across while we talk about the quantitative stuff. You know what is frequency distribution? Anyone in the group? Anyone in the group that what do you mean by frequency distribution in statistics? Please raise your hand and give you a chance. Okay. Now, frequency distribution basically is a distribution of values in your data set. Now, for example, if you collected values on, grades. If we collect values on your for example, grades in your last course, and we see that we got like you are 17 and the value, the result I got is maybe 5A, 2B plus, 6C, 2C plus. Now, if I plot them in the form of a bar chart where I have grades on the x-axis like A, B plus, B, C plus C, and their count. On the y-axis, I have count like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So whatever values I have in my data set. Now that bar chart is basically a frequency distribution, as the name suggests. So the count of each value in my data set is the frequency distribution. How frequent each, now let me put it in simple terms. How frequent each value is appearing in my data set, that is basically a frequency distribution. If I have got 8A out of 17, so the frequency distribution of A grade would be 8. If I have 3B, so it would be 8, 3, 2, 4, and so on and so forth. So this is what we meant by frequency distribution. Distribution of values or counting of values in your data set. And you can have a visual representation of this by plotting them, by creating them a bar chart of it. So the next is skewness. Have you heard this term before? Okay, we'll talk about this more as well. Basically, once you distribute or you plot the frequency, the values in your data set, typically we expect that the distribution of values in our population is normal. Now, what do you mean by normal population? For example, if we have 30 students in the class, the normal distribution of grades would be like we have people also, getting F grades, D grades, and A grades. So the people who are at the tails, like A, B, and people who are at the other extreme, other tail, like F, D, D plus, those would be equal, and you will see a spike in the middle. Like most of the people would fall in the mid, which is the average value. Like for example, the average is B. So most of the people would be, and we will have few people who would be getting A and A minus, and few people who would be getting, F and D or D plus. Now we will see that now once we plot this is basically, if you have more values on the A side, we will say that it is a skewed distribution. So if you get more values on the left side, you will say it is left skewed. If you have more values on the right side, we will say it's right skewed. I'll show you later on. Maybe you will get a better idea. Now, what is kurtosis? Kurtosis is basically once you do the frequency distribution, the peakedness, how tall your distribution goes, that is the kurtosis. As I just mentioned, that in any population, we see that whenever we collect data on any variable like age, weight, height, that should turn out to be a normal distribution. Normal distribution, mean and standard deviation, we'll talk about this. Okay. We will also, you will see that we will be using this term 95% confidence interval and 99% confidence interval. Now, 95% confidence interval means that there is a doubt of 5% only when you say, okay, this variable is when you do your hypothesis testing, you have to see that with how much confidence you can say that this variable X is related to variable Y based on your data. Now, that means that whatever your result is coming, that falls within 95. Once you say that it falls within 95% constant interval, it means that there is a chance of error by 5%. Just put it in simple terms. And once you say that it is 99%, your confidence interval is 99%, it means there is still 1% chance that your hypothesis may not be true. And I will tell you, once we interpret the SPSS output, that what are the things we look at to interpret the confidence interval. And you might have come across this term statistically significant. We use this term very often if you read the quantitative papers, that our results are statistically significant. Now, statistically significant means that the value of your test, whatever test you are running, falls within 95% confidence interval or 99%. And we typically look at the p-value to see that whether our results are statistically significant or not. If the p-value is less than 0.05, we say that your results are statistically significant at p is less than 0.05. P is less than 0.05 means that we are using 95% confidence interval. And if your p-value is less than 0.01, we say that we are using 99% confidence interval. Now you have more trust in your results. We will see. Don't get confused. Okay. Some of the basic things which we typically look at in like the basic thing we start with our quantitative stuff is the three things we typically look at: measure of centrality, measure of variability, and measure of shape of distribution. Now, what do we mean by measure of centrality? I'm pretty sure that you are familiar with these terms. Measure of centrality, mean. You must be familiar with mean. What is mean? Mean is an average value. For example, if I say that the average score of this group in quiz is 7 out of 10. Now that average value is my mean. Now some of you would be having score which is higher than the mean, like 9 or 10, and some of you would be having scores which are lower than mean, like 5, 6, maybe 4, 3, 2, and so on. So another so typically whatever statistical tests we run, we rely on mean too much, because mean is the basic thing which we deal with. Two other less commonly relied upon terms are median and mode. Median is the middle value. For example, if we arrange our values in ascending or descending order, what is the middle value? Middle value, that is mean, that is median. And mode is the most frequently occurring value in our data set. For example, if I collected data on your quiz results on a scale of 1 to 10, and I see that half of the class is getting 6, so 6 is the mode of the data. But forget about median and mode, just focus on mean. Mean is an average value. I'm pretty sure that all of you know this. So that's why I put it in red, because this is important. Another thing, the next thing which we typically look at our value is, for example, once we have the data, we look at the variability in the data. Now, typically variability is represented in maximum, minimum. For example, if I get value on your quiz on a scale of 1 to 10, if 10 is maximum and 1 is the minimum which students are getting, so my range would be 10 minus 1, 9. So maximum minus minimum would be a range of my values. The next thing is the variance. Now basically variance is how much your values deviate or far from the mean. For example, if the mean of the quiz is 7, some of you are at 10, some of you are at 9, some of you are at 2, some of you are fine at 1. Now we see that once the values which are close to the mean are 9 and 10, and the values which are 1, 2, 3, those are far from the mean. Now the sum of these variations, that is basically the variance in this variable. The more closer you are to the mean, the more accurate my prediction would be, because mean is representing the whole group, the whole population. If I say that the mean score for this quiz is 7, which means that on average people are getting 7. So the more far you are from the mean value, the more error I would have in my predictions. And once we take the square root of the variance, we get standard deviation. Now standard deviation is a very is a very common term. Mean and the standard deviation is the two common terms which we very often use while we do the quantitative stuff. The standard deviation is nothing but the square root of the variance. Okay, now
Doctor?
yes.
Excuse me, doctor, let me interrupt you for a second. Doctors, students are like writing the answers in the chat box. And also there's one question from a student. So will they
Sorry, I couldn't look at it.
Yeah.
Because, once the screen is shared,
Yeah.
Okay, sorry, because it just goes in the backdrop while you have this screen. Okay, we can talk about this. Okay, so yeah, freshman, so for senior, yeah, nominal variable, exactly, percentages. So higher the confidence interval is, the most toward the research is. Yes, that's true. The higher the confidence interval, you can say with more confidence that your results are robust. If the p-value is less than 0.05, which means, now when you're saying, because once we interpret our statistical results, we do not talk about the confidence interval, we only talk about the p-value. But once we are saying that the p-value is less than 0.05, it is an indication that my confidence interval is 95%, which means still there is a 5% chance that my results may not be true. And once I say that my p-value is less than 0.01, my confidence interval is 99. Now I have more confidence in my results. This is one thing. The second thing is, whenever the p-value is greater than 0.05, we do not interpret those results, because anything less than 95% confidence interval, typically, this is the norm in my field, and I think this is the norm in most of the field, because I've seen in some fields people, even take the values within 90% confidence interval, which means p-value should be less than 0.1. But in most of the cases, in majority of the cases, in majority of the quantitative research, whatever we come across, the lower, acceptable confidence interval is 95%, which means p-value less than 0.05. Okay, so yes, exactly. We reject the null hypothesis whenever p-value is less than 0.05. I can also take the questions at the end if you want. Okay. Now moving on, the next thing is, we talked about, this is a picture from the internet, you can see, and this can give you that, because we talked about skewness and kurtosis, because that tells us the shape of the distribution. Now you can see that here on the kurtosis, this is, if you see this, purple line, that is the shape of a normal distribution, frequency distribution, which means you have majority of the values in the middle and you have less values on the sides, two extremes. This is how we expect that the values on a variables are distributed in a population. So, but we do not, very often we don't see these trend, the normal distribution trend in our data set, because when we are doing research, we collect sample from a population. And sometimes, the sample may not be the true representative of the population. Now that is another, thing. So kurtosis means that how peakedness of your distribution. So if it is above the normal distribution, we say is positive, and if it's like this, you see this blue line, we say it's a negative kurtosis. And skewness is, for example, again the same thing. If it goes, if you see that if your mean value is in the middle, and if you see that a lot of the values are, on your left hand side, close to the y-axis, that is the positively skewed, and if the values is on the right hand side, that is the negatively skewed distribution. So this is what we meant by skewness and kurtosis, because these are the terms which you would come across while you would deal with quantitative stuff. Because as I just mentioned, that most of the time the social sciences data is not normal. But we say that if your data is quasi-normal, we can still we can still go with the main analysis, because this is one of the assumptions which we have to see before running the main analysis. For example, if your skewness, because typically we look at the skewness and kurtosis value to see that whether our distribution is normal or not, frequency distribution. If the kurtosis value is within the range of ±1, we say the ORCAT is very good and we are good to go for the main analysis. But most of the time we can accept kurtosis value within ±2. If the kurtosis value is within ±2, we can accept it. Now, similarly, same is true for skewness. If the skewness is also within the ±2 range, we can go with the main analysis. Okay. Now, once we go with the once you get the data, you collected data, you have the data with you. Now, what are the things, the 4 things we typically do? There are a couple of others, but I'm not going to talk about here. Like we sometimes also look at linearity, we look at homoscedasticity, but I'm not going to talk about here because I'm just going to talk about some of the most commonly looked upon stuff in the data screening. The first thing you need to see that your data should not have any aberrant values. Now, what do you mean by aberrant values? Aberrant values means those values which are not part of your, which are not part of your, normal scale range. For example, if you are measuring blood pressure and you get a blood pressure value of 400, now that's not possible, isn't it? So that is an aberrant value, which means that either you recorded it incorrectly, or either while you are putting data from your paper into the SPSS or Excel, you did a typing mistake. So typically, now how we identify the aberrant value? We look at the maximum. We just talked about the maximum and the minimum in on the previous slide. We look at that what is the maximum value in our data set, and we look at the minimum value. Now, the maximum value can tell you that whether your values are out of range or not. Now, for example, if you're measuring something, if I'm measuring your happiness level on a scale of 1 to 5, and in my data set, I get a value of 10, now that is not possible. Maybe you know that the actual value is 1, and while putting data, I just, I just pressed 0, and that made it 10. So, which means that I need to go back to my hard copy, version, or maybe I need to remove that record, or maybe I just need to use my common sense to see that 10 is not possible, 0 is not possible. So most likely it is 1, and I pressed 0 by mistake. So that's why it turned out to be 10. So this is how you can find the aberrant values. The second thing we typically look at are the outliers. Now, outliers are the values which are possible in the population, but those outliers made your distribution skewed. Now, for example, if I'm collecting data on income level of graduate students at UE University, now I get a now income level means like maybe your monthly income, and I get a value of 500,000 dirhams from one of the respondents. Now you see that this 500,000 dirhams is an outlier, because this is a value which is very far from the mean value of my group. And outliers, typically, once we do the main analysis, they we have to remove them, though we have to remove such cases from our analysis, because they disturb your main results. And sometimes once you remove the outliers, you see that you see the results are altogether changed. So this is the second thing which probably you need to look at into data set and remove the outliers. We will see that what are the techniques we used for removing the outliers. And then the third thing is normality. There are 2 tests which we're going to talk about, which we use for testing the normality. But typically we can also look at skewness and kurtosis values. If skewness and kurtosis values are within range of ±2, I think we are good to go to the main analysis. And the fourth thing which we typically come across in our data set is missing values. Whenever you survey, you will see Sometimes like for you have 50 questions in your survey. Sometimes people just responded to 40 and they just leave 10. Sometimes you see people not responding on the demographics. So from that perspective, uh, uh, you know, uh, if you remove all those cases, if you have a small data set, there's a risk that you are going to lose data. So from that perspective, uh, sometimes it is not advisable to remove cases which have missing values. Rather, there are techniques which people use to replace missing values so that your data is not lost. So these are typically the 4 things which we need to look at while we are doing data screening. Okay, so now I'm going back to the SPSS. Okay, so I shared a link in the chat window in the beginning of day 1 folder, where you have in assignment this file sleep3ed.sav. Okay, so we are going to work on that file. So let me just open the SPSS. Okay, I unshare. Now, okay, can you see this screen?
Yes, doctor, we can see.
Okay. Now, whenever you open SPSS, you come across this window. Now, if you look at this window, here at the bottom, you have 2 tabs. One is the data view and the other one is the variable view. Now, first I'll talk about the variable view. Now, this variable view is a place where you have to declare your variables. You have to configure your variables. Now, for instance, the first column is name. Okay, the second is type, width, decimal, label, values, missing column, blah, blah, blah. Now, for example, in name means you have to name your variable. For example, I have a variable, okay, first variable maybe I do here is serial number. So I SRNO, this is the name which I give to serial number. Now serial number is like 1, 2, 3, 4 and so on. Now what should be the type for serial number? Now if you click on the type, you have numeric, comma, dot, so on and so forth. Now typically we deal with numeric values. Now anything which comes in the form of number, that is numeric. 1, 2, 3, 4, 5, 6, so on, numeric. And anything which is in the form of alphabets or alphanumeric, that we call string, here second last. But we can't sometimes you put the values in the string and we then convert it into numeric. I'll tell you how to do that, because SPSS only understands the language of numbers. Quantitative data stuff only understands the language of numbers. So most of the time we go with numeric. So I just click numeric, I click OK. So my first variable is serial number, its type is numeric. Width, by default it is coming 8, so just keep it 8. Then you have decimal. Now decimal means how many places you would like to have after decimal. Serial number is just without decimal, so I can just click here and I can make it 0. Now label. Label is because name of the variable is a short name. Label is, sometimes you have the questions in your survey. So label is that what is that question. So maybe I can use a full name here as serial number into MBER. So that would be my table. Yes. Okay. Now values for the time being, just keep it none. Missing, keep it none. Column none. Okay. And then you have here measure. If you click on the measure, you have three options: scale, ordinal, and nominal. You remember we talked about nominal, we talked about ordinal, and scale is the same thing what I call continuous. If the value is like on a scale of 1 to 5, on a scale of 1 to 10, that is my scale variable. Ordinal, I told you that if you have categories which can be ordered in a logical order, and nominal is like for you have only two categories: dead or alive, past or present. So what should be the measure for serial number? Anyone? Just write in the chat window if you don't want. So what should be the measure for serial number here? Yes, excellent, Bernadette. Scale, yeah. So it is scale. Scale is same as continuous, because it would be my serial number would have values like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah blah blah. So it should be this. Okay. Now maybe my second variable is I would like to have values on gender. Okay. Now gender is male and female. But again, as I just mentioned, that even if you record values on like male and female, we have to code it into numbers. Like for example, 1 is representing male and 2 is representing female, or 0 is representing male, or 1 is representing female. So but for the time being, maybe you can just here you can put string. Okay. And it is okay, genders, it would be same as gender, and measure would be, what would be the measure for gender? Let's see. Okay, good. Ali Al Rahman nominal, Halima nominal, excellent. Laila, excellent. Okay. And once we here selected string, you see that no longer should this, you see the option of scale here, because scale is a continuous measurement in the form of numbers. So you don't see that. So here we put just nominal. Okay. Let's put another variable, which is maybe marks. Okay, so that should be numeric. Yes, scale is for numeric type. So marks would be numeric because that comes in the form of a number. Okay, we don't want to go to the decimal, so I just make it 0. Okay, marks quiz. Marks quiz 1. Okay. Okay, so this is okay, and measure would be scale. Now, yeah, negative it would be scale because we are on a scale. Marks are on a scale of on 1 to 10. Ordinal is for categorical. Like for example, if I put here grade, that would be an ordinal, like A minus A, A minus B plus B, and so on and so forth. So this is where you configure you declare your variables. Now I click on the other, which is data view. Now you will see that whatever variables I declared there, those are appearing here. Now here I have to put in my data. I can even copy paste data from Excel. I just select, if I for example have data on these 3 things in Excel, I just copy those 3 columns and I can paste those here. But I can enter here manually as, for example, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 students. What this 89 is? Which value is this? Anyone? Let's see. Aberrant. Excellent. Really excellent. So this 89 is an aberrant value. You see that while typing 8 and 9, I type them in the same box. So this is how, like, for the time being, I just keep it here so that we can see that how we will identify it in a bigger data set. Now gender, okay, for example, this is male, female, female. Okay, I'll just copy paste. I can this select, Control C, same, Control V. Okay, and then okay, I have one male, female, Control C, Control V. So like you can copy paste values. It's very easy. And marks, we say that it's on a scale of 1 to 10. So 2, 4, 6, 8, 2, 4, 8, 10, 3, 4, 5, 2, 10, and so on. So I have a data set of 9 students. I have their gender. Now, as I just mentioned that SPSS understands the language of number. So my preference would be that I convert this values male and female from string to numerical form. I code them in a way that I say yes, code into 0 and 1. Okay, we say that male is okay, female is 0 because F come alphabetically. This is my own logic, and male M comes later, so it come at 1. So how to code them into 0 and 1? I'll go back to variable view. Okay, and side by side you can see that here you have the save button. Once I clicked save, it asked me that where should I save it. So I'm just going to save it into this assignment case number 1. This practice data. Okay, I save it. Okay, so now I go back to the variable view. If you look at this column values, sorry. Now because I want to code gender, and my coding scheme is that I want to code female as 0 and male as 1. I would click here at the values. Once you click at the value, you will see this little 3 dashes and this blue box. If you click on this, you will see another pop-up box opening up. Now it tells you that value and label. Now, anyone who can let me know that what should I put in the value and what should I put in the label here? Just write in the chat window, anyone? Okay, where should I put? Okay, 0 in the value, and what should in the label? Female. Good. Okay, so I put here 0 in the value and label. I will use the same spelling what I used in my actual data set. Otherwise, some of them and I press add. Now, what next should I do? What should I put in the value? Let's see. Okay, value 1. Good, Nigar. And yes, label is male. Okay, value is 1 and label is male. I just added. I pressed OK. So I have recoded this into 0 and 1. Now, if I go to the data view, wow, I don't see. I see it's still male, female, male, female, male, female, male, female. What should I do? Why it's not coming in the form of 0 and 1? Anyone? Edit. Halima, you are saying I should edit with capital M. Okay, let me check again. Go back.
I think we need to go under edit, in the edit, the tab, the upper right, the upper left, beside the file. We need to replace all the
No, I don't think so. Wait. If I change this string numeric, press OK. These are removed. Now, whatever missing values, let me do Control Z. Whatever missing values you have in the data set, that would be represented by a dot. So if I put, like, if I change, I can't do change here because I like did this. It is 0.0, 1.0. Okay. Go to the data view. So usually once we do this, click on someone else is saying something. You are saying that I should go to Halima. I should go to
yes, doctor. Under the edit, we need to go actually highlight first the column of gender, yes, and then edit, and then replace. Under it will be with the find. You can go to the find.
Find.
Yeah. And then yes, replace. Yes, you choose that. So you write find female and then replace them with 0. And then
okay, this is, yeah, but you know that will not be appeared the way we did it here in the values. So this is another way what you are saying, but the way I'm trying to do it, that like you can switch between, because if you look here on this, you know, 1 and A, this typically, I don't know what mistake I'm doing here, but it retains both. If you look here, like the value labels, can you see this button 1 to A, where I'm you know, putting my mouse?
Yeah, you're right. This is another way.
Yeah, because it the way you are telling me, that's fine, but that would altogether you lose this male and female English thing stuff. It would be like one-time change and it will stay forever. But the way I'm trying to do it is once you replace it, once you click on this button, it converts between English to one to coding, and I don't know. I think some what mistake. Okay, hold on.
Hi, doctor. How about changing to integer, because it is 1, 2, 3. Sorry, it's 0, 1.
The type?
Yes.
No, but because the type, if we change it, it will remove them. If I make it numeric, it will not take male and female values. Yeah, I'm missing out here on something. Okay, so I'll just figure this out, that what mistake I'm making. But typically, you know, usually when I do this, you just put into the values and you come to here and you put on, you click on this. It will, if it is pressed, it will show you 0101, and if you click again this, it will show you male and female. So we'll see that what mistake I'm making. We'll figure this out. Okay, but this is the way that, like here you put the values, and it will be shown in the data. Now, the next thing is, for example, if I want to make another variable, which is a product of this marks and serial number. Now I can do that, and that is pretty much doable. You go to the transform, you click on this compute variable, and you name the new variable. For example, I want to do serial marks. This is my new variable. I'm just giving you a demonstration, because sometimes we have to multiply two variables, we have to divide two variables. So this is how we do this. For example, if you want to create a new variable which is a product of the serial number and marks, I can give any name here, serial underscore marks is equal to numerical expression. What is my numerical expression? My numerical expression is, you can just put in the brackets. You just select the serial number, click on this arrow, it will bring it here, and you press on this multiply, and then you press on this marks on quiz, you bring it here. And if you press on OK, check for missing operands. Okay, this, I think I just pressed on the X instead of X. You have to put this star. And if I press at OK, you will see, now you can see another variable. If you come here to your data, you will see another, the same variable which we computed, SR underscore marks, and this 2 is basically we receive it by multiplying 1 multiply 2. Here you get 8, 4 multiply 2, and so on and so forth. Like similarly, for example, if you want to compute any other variable, you just have to declare here the name of the variable. And if, for example, you want to, because you will be doing some of these stuff in transformations, we will do in the next class. So you can put any formula. It has also built in some formulas here, functional groups, if you see on the right, but you can create your own formula the way we used to do it in Excel. So if you want to divide any variable, you want to multiply some variables, you want to minus, plus, anything here in compute variable command, you can do this stuff and it will come here in your data set. Okay. Now, so this is another thing which we would be using. The most commonly used button in the SPSS is analyze. All of the statistical tests which we run are under analyze button. So this is the most commonly used tab. Now, for example, we just talked about mean, standard deviation, skewness, kurtosis. We call them the descriptive statistics. So if you come down here, you will see this tab of descriptive statistics. Now, for example, let's first look at the frequency distribution. So if I first click on frequencies, there is another box which is open, and this box here you will see the list of the variables here. Now, which variable I want to have frequencies on? Maybe I'm interested in looking at the frequencies of marks. So I just select marks, I click this arrow, and it will go into this box, variables. Now, if I go to the statistic, if I click on this first button, statistics, it has different options. For example, we talked about the dispersion. So I'm interested in looking at the standard deviation. Maybe I'm interested in looking at the range, minimum value, maximum value, variance. I am interested in looking at the mean, median, mode. So whatever I check from here, that would be displayed there. I'm interested also in looking at skewness. kurtosis, and I just click on continue. Similarly, the next you have charts. I click here on the charts. I'm interested in maybe the histogram, and on the histogram, I'm interested in looking at the normal curve. Okay, I just here continue. Forget about this, style, bootstrap, and things like that. Now there are two options. You have here two options. One is OK and the other is paste. If you click on the OK, the results will open in a new window. If you click on the paste, another window would be open which has a syntax for these whatever test I've selected. It has a syntax for those. So once I click on paste, you will see that this will open in a new window. Can you see this new window, or it is not visible to you? Huh? Not visible, which means that it's not automatically shared. So okay, let me try to share it. So once I click on the paste, hold on. Okay, so I stopped the earlier share, and yeah, okay. Once I click on the paste, I will see this screen. Now, can you see this new window?
Yes, doctor.
So you can see that here, whatever buttons I clicked, this is giving to me in a command form. So it says dataset active, dataset 2, frequencies, variables, marks. You can even change it. If you are familiar with the syntax, you can write here your own commands. But for the time being, just forget about this. But the idea is that if you are familiar with the syntax, instead of going there, you can modify the syntax, you can put the variables names, and it can run for you. Now, how to run it from here? You just select it like this, the way I selected, and you will see a green button, this green button here. So after selecting, once I put the green button, the output will be opened in another window for this. Now, let me just share it, because it will not be automatically available. Where is the window? Output window. Output. Long list here. So, okay. Can you see the screen? Okay, good. So once I click on the run, you see that you have this window. Now, if you look at this window, we see that it is giving us the statistics on marks in quiz. First, it tells you number. We have 9 readings, so valid are 9. Missing is 0. None of the value is missing, which is good. Mean of the quiz is 5.33. Median is 4. Mode is 2. Standard deviation is 3.2. Okay, if you look at the skewness and kurtosis, skewness is 0.64 and kurtosis is minus 1.3. Now, do you think that this is a quasi-normal distribution? Anyone? Anyone? Do you think that this is quasi-normal by looking at the skewness and kurtosis statistics? We talked about, yes, Ibtisam, yes. We talked about that if the values of the skewness and kurtosis are within plus minus 1 limit, that is good. But if those are within values of plus minus 2, even that is also acceptable, and we are good to go to proceed to the main analysis, which means our distribution is not significantly departing away from normality, and it is close to normality. So, and if we look at here, the skewness value is 6.4. Okay, and no, not 6.4, 0.64, and kurtosis value is minus 1.3. So these are within the limits of plus minus 2. So we are good to go. Similarly, it gives you range. Range is 8. 8, as I told you, that range is maximum minus minimum. The maximum value in our data is 10 and the minimum is 2 and the range is 8. So typically we look at, you know, the missing values, how many missing values we have in our cases. What is the mean value? Mean value is 5.33 on a scale of, you know, we have a scale from 1 to 10. And then we look at standard deviation. Standard deviation is 3.2. Now 3.2 standard deviation tells us that there is a good variability in our data. The lower the standard deviation is, now for example, if standard deviation here is 0, what does this mean? If standard deviation is 0, what does this mean? Anyone? Let's see who is genius in the class. Yes, there is no variance. It is not far from the means. If standard deviation is 0, which means all the values in your data set are 5.33, which means all the values are actually the mean values. If I, you know, have a data set of 10 values and every value is 555, mean value would be 5 and standard deviation would be 0. Do you think that variance is good or bad in a data in order to have variance? Variance, not so good to have variance. Aha, anyone else? Halima is saying variance is good. Nigat is saying variance is good. Okay, why should we have variance? You know, look, now variance is good. The reason why we say the variance is good, because if there is no variability in the data, you will not be able to explain anything. With quantitative data analysis, we explain variance in the data. We do nothing else, we only explain variance. If all the values of you know, marks in quiz are 555, and for example, let's take another example. If you have the same value, if you collected values on blood pressure and if you collected values on quality of sleep, now all the values on the blood pressure are same, what would you explain? You're not able to tell that what is predicting high value and what are predicting low values. So no variance means 0 result. So variance is, yes, important. You need to have variance. And that's why it is important to look at the standard deviation statistics, that how much standard deviation you have. The low standard deviation means that all people are reporting values which are close to mean. High standard deviation means that you have variability in the data, which means data is good, and you can explain that variability by introducing other variables in your statistical models. Now, if you go down here, you can see now this is the frequency chart. Now, this now tells us that the people who scored 2 are 2, people who scored 3 are 1, who scored 4 are 2, who scored 5 are 1, who scored 8 are 1, who scored 10 are 2. In total are 9. Okay. Now, and this is the histogram. Now, the frequency distribution are plotted by histogram. Now, you can see this normal curve here. Now, typically, this is the normal distribution. Like you have values here. Like you should have students in the class who should have scored 0, who should have scores 1, and like this. But this distribution is not a normal distribution, because you can see that. But as I mentioned in the beginning, that we rarely find normal distribution once we do the quantitative. Whenever we plug data, we rarely find normal distribution. And that's why we always aim for quasi normal. Okay, so this is how like you can see the frequency chart. You can see that whether the distribution is normal or not. You can also look at mean standard deviation, skewness, kurtosis. You can also look at, by looking at this maximum and minimum value, you can see that whether you have aberrant values or not. If here I have a maximum value of 100, which means this is outside my scale limit, which means that that is an aberrant value which I need to investigate. And you can also look at here the missing values. Okay, so this is the output window, and you can always save it. If you just click on the save button here, it tells you, it asks you for the name, it asks you for the destination where you want to save it, and this is how you can save it. Okay. Now one more thing before we end the session is let me just open these up, because then I have to. Okay, so in your, the link which I shared for today's material, you have assignment, one folder, you have this questionnaire. Now, this questionnaire is typically like, because I just wanted to give you an idea that where the data has come from. Now, this is the questionnaire for sleep. And you see, can you see this PDF file? Oh, sorry. I think I pressed the wrong button. Sorry. Let me just, yeah, it's here. Okay, thank you. So you have like the type of variables you have here is gender, male and female. What is the nature of this variable? Anyone? You can just type in the chat window. What is the nature of this? Yeah, nominal. Very good. Very good. Excellent. So this is, so the researcher has gathered like gender, which is a nominal categorical variables having two categories. So we call it a nominal variable, male, female. Age here is a continuous variable because people can write any age, whatever age they have. You don't have categories for this. Then you have marital status. You have 4 categories. Again, this is a categorical variable with more than 2 categories. Then you have, the highest education level completed. You have weight, which is continuous. You have height. Overall, how would you rate your general health? Now, general health is on a scale of 1 to 10, from very poor to very good. Physical fitness, current weight, do you smoke? Yes, no. Again, yes, no is a nominal variable with 2 categories. If yes, how many cigarettes do you smoke per day? Now that is a continuous variable. People can say 20 cigarettes, 100 cigarettes, 1 cigarette, maybe 10 cigarettes. So how many standard alcoholic drinks do you consume on an average day? Again, this is a continuous variable or scale variable. 100 drinks, 1 drink, 2 drink, 10 drinks. How many drinks containing caffeine, coffee, tea, cola do you drink per day? So again, this is a continuous variable. So the smoking status is binary. Do you smoke? Yes, no. You can call it binary or nominal. How many hours sleep do you get on weeknights, on weekends? Again, this is a continuous or scale variable. How many hours do you think you need to feel the next day? Did you have trouble falling asleep? Blah, blah, blah. So on and so forth. You see that this is a questionnaire. The researchers has gathered data. Now, the SPSS, you have the SPSS file, and this is the nomenclature. You have description of the variable, which is identification number. SPSS variable name is ID, gender, and the coding is 0 is female, 1 is male, and so on and so forth. So you can go into the code book as well. This is how typically we prepare code book before we, go for the data. So once, for example, once if you are a researcher, you distributed this survey and you got your data in. And now let me just open that data to, sorry. File, okay, file open data, and sleep3ed.save. So once I open it, you can see this. This is my variable view. So you have all those. So sorry. Can you see this? No. I have to share it again. This is very annoying, but we have to bear with this. I wish we could have been face to face. It would have been a great fun, to learn this face to face. Okay. I hope you can see this again.
Yes, doctor.
Okay, great. So if you here go to the variable view, you have all these variables the same way, like this is the name, ID, type, label. You see here, the whole questions here, the values. I think the mistake we were making there is here, if you look at here, for example, the variable marital status, here they have made it numeric. And then they declare the value that 1 is single, 2 is married, 3 is divorced, 4 is widow. So I think the mistake I was making was we here the type we made it string. So if we just made it numeric, because here we are declaring numeric values, it would be okay. Now if you go to the data view, the thing I was telling you, if you click here on this button, which says 1 to A, if I click here on 1 to A, you can see that all those 1 values now are, you can see the decoded values. You can see this English stuff here. So these are the decoded values. This is what I was trying to do there, but now we realize what mistake I was making. That the type, because if we are putting 1, 2, then we shouldn't make their string. We should make it numeric. And if you just want to go back to the one like coded values, I just click this button again, and I would have my coded values in there. Now all these dots, these represent what? These dots. This dot here, here. Why these dots are here? What does these represent? Let's see who says missing. Excellent, Halima. These represent the missing values. Okay, now you have this data file. Now what you are supposed to do? Let me just share. Okay, I unshare this. I share again. Okay. So this is your assignment, because this assignment is a little bit big because you have 2 days. So I thought that I should make it a bit more comprehensive. The data file sleep.ed.save is condensed form of study conducted to explore the prevalence and impact of sleep problems on various aspects of people's lives. Staff from a university in Melbourne, Australia were invited to complete a questionnaire containing questions about their sleep behavior. The file sleep_codebook.pdf contains complete questionnaire and related coding scheme. The final sample consisted of 271 respondents. Now, please perform the following analysis on this data set. Question number 1, analyze the structure of missing data for all variables. Because we didn't do that, so you shouldn't be doing this today. But you can at least, from the frequency distribution, you can see that what is the percentage of missing on each variable. So this is you need to do, because I told you that once we went to the descriptive frequencies, we have there in the missing values. So you need to tell me that what percentage of missing values you have on each variable. Just forget about number one, count number of missing values in each case. This, because I didn't tell you that how to do this, I'll tell you this in the next class. Which method you will use to replace the missing values? Justify your choice. Again, we didn't do this. We didn't have enough time. I was thinking that we would be moving with the speed, but unfortunately not. So we'll do this in the next class. Okay. Identify outliers for each, for all scale variables. Now this you can do by yourself to do this, but I'll tell you in the next class as well. If you read the whole slides, you have some information that how we identify the outliers. But one way of doing this is, for instance, if you look at the, but we didn't talk about this. We didn't talk about the standardized score. So forget about this as well. Okay. This one you will do. Question number 3, do a univariate analysis of following 8 variables: weight, height, health rate, fit rate, weight rate, quality of sleep, impact 1, impact 2. This analysis should allow you to assess the central tendency, dispersion, and shape of distribution. We talked about these 3 things and we just did that. Central tendency is mean, median, mode. The dispersion is variance and standard deviation, and shape of the distribution is skewness and kurtosis. Please include graphs and relevant statistical tests and their interpretation. So just include the histogram with the shape of the normal line. This you should be doing it by yourself. Create another variable which is a multiplication of scores on weight and height. Name the variable as WEHE. We did that, so you have to do that. Question number 5 is make 3 categories of question. How many standard alcoholic drinks do you consume on an average day? Alcohol. Store those into a new variable named alcohol_cat. We didn't do that, but you should try to do this. You have YouTube, you have Google. The idea is that how we, because sometimes we have to do that in data analysis, that we have to convert a continuous or scale variable into a categorical variable. Now this is what we are trying to do here. You have a continuous variable which is alcohol, that how many alcoholic drinks you consume per day. I'm just giving you a way that how you can do this. You have to make 3 categories, which is low, medium, and high. Now, first you just look at the mean value. What is the mean value of alcohol variable? Now, mean whosoever is, and then you have to look at the standard deviation. Now, you can say that the mean plus standard deviation 1 is medium, mean plus standard deviation 2 is high. Similarly, mean minus 2 standard deviation is something low. So you can decide your own cutoff criteria, but at the same time you can just keep it simple. You say, okay, mean value is medium, anything above mean is high, anything below mean is low. So you have 3 categories. Mean is medium, anything above mean is high, anything above mean is low. So try to do is, because in the SPSS you have an option recode into different variable. There is a button in the data, and under that you have this recode into different variables. Try to do this, but if you are unable to do this, you will do it in the next class. No worries. Yes, below mean is average, below average and above average. That's perfectly fine. Okay, I think we already exceeded by 11 minutes, so I don't want to hold you a longer time. I know that some of you are fasting, and I don't want that. I don't want to drain your energies. So just try to do whatever you want to do after this assignment, and whatever is left, we will discuss it and do it in the next class. Don't worry, but do your 100%, because this is how we learn. And this is, the more you play with this software, the more you will learn. this is not a machine, and you are not kids that where I should ask you that, oh, don't touch this, you are going to spoil this. No, the more you play with it, the more you will learn. So just practice around, try to press different button and see that what results you are getting. Okay, thank you very much. And have a blessed iftar, and inshallah, I'll see you on Wednesday. Take care. Best of luck.
Yeah, thank you so much for the informative session, Dr. Abdul Karim. And also for the attendees, I would like to remind you all the second session will be on Wednesday at the same time, 3 p.m. To 4:30 p.m. So have a nice day to you all. Thank you, Doctor, and thank you everyone for attending.
Yeah, okay, Halima, you are asking about, because I don't have your emails, so the link Bernadette shared here on the chat window. So please double check that if you are able to access the link or not. And if somehow due to any reasons you are not able to access the link, please send me an email and I'll send the files over to you, because I don't have your emails, unfortunately. Okay, take care. Bye bye.